discuss conditionals and biconditionals. So today, I'll first talk about conditionals and then talk about biconditionals. Let's begin with conditionals. In some ways, these are really the glue of logical reasoning. I think when we think of paradigmatic cases of people thinking clearly and logically in English, we tend to think of them as using a lot of if-then statements. To begin, let's introduce some vocabulary that will allow us to speak more easily about the different components of a conditional statement. Take the conditional, if you study hard, then you will pass Phil 180, that is, this course. Here, you study hard is what is called the antecedent, where generally any statement of the form if P then Q has P as its antecedent. It's the thing that immediately follows the if in an if-then statement. The statement which follows the then in an if-then statement is called a consequent. Thus, in the English conditional, if you study hard, then you will pass Phil 180, you will pass Phil 180 is the consequent. When we speak more abstractly of a conditional of the form if P then Q, Q is the consequent. If-then statements can be translated in a number of ways in English. For instance, we might say if P then Q, we might simply say if P Q, we might say Q if P, P only if Q, P is sufficient for Q, Q is necessary for P, and P requires Q, are perhaps the most paradigmatic ways of expressing if-then statements. But we're not done yet. There's even more ways to express if-then statements. P entails Q, P implies Q, a bunch of what we might call thick verbs, which I'll describe later, like P renders Q, P yields Q, P produces Q, etc. In case of PQ, provided that PQ, given that PQ, and on the condition that PQ. Let's see what this looks like with a concrete example, starting with the most basic one. If Khalifa is human, then Khalifa is a mammal. The following are all equivalent ways of saying that same simple if-then statement. Khalifa's being a human suffices for his being a mammal. Khalifa's being a mammal is necessary for his being human. Khalifa's humanity requires that he be a mammal. And Khalifa's humanity entails that he is a mammal. Here are two more examples involving what I called thick verbs before. Suppose we're told washing your hand decreases the chance of infection. That's the same as saying if you wash your hands, then the chance of infection decreases. Here's another example involving a thick verb. Suppose we're told that paying off the professor will produce the desired effect. But we want to make this amenable to analysis in first-order logic. We can set this up as an if-then statement. If the professor is paid off, then the desired effect will be produced. Of course, it's in your interest to figure out whether this is true or false. Just kidding. Okay, so now that we have a rough feel for how if-then statements work, let's get a better sense of the underlying logic behind them. So the goal here is to treat if-then as truth functional, and we'll see that that's somewhat messy in a few minutes. But for now, recall that truth functionality basically says that when you have a complex expression, you can make sense of it by looking at the truth values of its atomic sentences. So what that means in this particular case is that conditionals are going to be true on the basis of the truth and falsity of their antecedent and consequent. We represent if P then Q in logic as P arrow Q. So P is going to be your antecedent and Q is going to be your consequent. Now, the truth conditions for P arrow Q, what's sometimes called material implication, is really pretty straightforward. Basically, the whole conditional is false when the antecedent is true and the consequent is false, and otherwise it's true. Okay, so it turns out that thinking of conditionals truth functionally has a mixed track record, if we want to put it that way. I'll start off with the good news and then show you the bad news. So here's some good news. There are some conditionals which are true when both the antecedent and the consequent are true. For instance, if Khalifa is human, then Khalifa is a mammal is a true conditional in English. And furthermore, it's true that I am a human, and it's also true that I am a mammal. This corresponds to the first row in our truth table for if-then. There are also examples in English that correspond to the third row on the truth table that we see here. In this case, we have a false antecedent and a true consequence. Here's an example. If Khalifa is a dog, then Khalifa is a mammal. The antecedent, Khalifa is a dog, is false. The consequent, Khalifa is a mammal, is true. And the whole conditional is also true. We can use a similar example to show why the fourth line on the truth table, where both the antecedent and the consequent are false, is sometimes the right way to interpret a conditional. Consider, for instance, if Khalifa is a dog, then Khalifa is a canine. Now, it's false that I'm a dog, it's false that I'm a canine, but the whole conditional itself is true. If I was a dog, I would be a canine. All right, so the good news is that some conditionals in English track with the material conditional in first-order logic. The bad news is it doesn't always work this way. Sometimes first-order logic delivers things that sound super weird in English. What I'll do is I'll go through each of those rows of the truth table again and show you that we can get this weirdness. So here's the first bit of weirdness. Take that first row on the truth table. There's lots of conditionals which won't work if you have a true antecedent and a true consequent. Here's just one. If 2 plus 2 equals 4, then Middlebury is in Vermont. Unfortunately, the weirdness doesn't stop there. Let's go to that third row on the truth table where we have a false antecedent and a true consequent. We can get all sorts of weird conditionals, and we're not really sure that they're true or false. They're just so weird, right? Example, if the moon is made of green cheese, then 2 plus 2 equals 4. As you might have guessed, the weirdness doesn't stop there. If we go to the fourth row, where both the antecedent and the consequent are false, we end up getting weird conditionals there too. Here's just one example. If Khalifa is a dog, then the moon is made of green cheese. It's false that I'm a dog, it's false that the moon is made of green cheese, and the conditional is also super weird. So we do see that there's a mixed verdict when it comes to representing if-then statements in English as the material conditional in logic. And the main problem is just that it appears that if-then statements in English are not simply truth functional. In other words, you can't just know the truth and falsity of the antecedent and the consequent and thereby know what the truth value is of the whole conditional. Getting into that and really sort of solving that puzzle puts you beyond being a mere user of first-order logic and into the realm of being a theorist of logic and of language more generally. And so you would be doing work as a linguist or as a logician or a philosopher of language or something along those lines. If you're interested in this, I'd strongly encourage you to consider taking the sequel to this course, Semantics, Logic, and Cognition. Okay, now let's talk about biconditionals. You'll see that this largely piggybacks off of our discussion of conditionals. Typically, biconditionals are interpreted as if and only if. Thus, we see P if and only if Q is how we would represent the biconditional. Biconditionals are also sometimes called material equivalences. For example, Khalifa is a human if and only if Khalifa is a member of the species Homo sapiens. Would be a biconditional. As its name suggests, a biconditional is two conditionals. It's basically if P then Q and if Q then P. We can see this if we think about some of the translation tips we learned about conditionals earlier in today's lecture. For instance, we saw from earlier that P only if Q is translated as if P then Q. Furthermore, P if Q is translated as if Q then P. It's just moving around the words. So if we look at those middle two rows, what we can see is that P if and only if Q is just two conditionals, if P then Q and if Q then P. And that's exactly how we started off. So we can just see that basically the double arrow is shorthand for the conjunction of two conditionals. Not surprisingly, necessary and sufficient works just the same way. So another way of expressing the biconditional is to say P is necessary and sufficient for Q, and you can basically run through the same reasoning. All right, so now that we have a feel for what biconditionals are saying, let's start to think about their underlying logic. And what we'll do is we'll build a truth table on the next slide. The core idea behind a biconditional is that the truth conditions of the atomic sentences have to match. So if P is true, Q is true, and if P is false, Q is false. And this is what we see on the truth table. We see that P, if and only if Q, is true just when P and Q's truth values match, that is, on the first and last rows of the truth table. Thanks, and I'll see you at the next lesson.